Hey guys, today we are in lesson 2 in chapter 3 or unit 2, and we're going to talk about slope and rate of change. So this is going to be a complete review, so it shouldn't be anything too stressful. I think people try to make slope too mathy, and I mean it's slope if you just think about going up a hill or going down a hill. Like that's the basic premise of slope. In algebra, you probably called it rise over run. Um, then you were also probably introduced to the formula like y2 minus y1 over x2 minus x1. They all mean the same thing. Positive slope goes uphill. And when I say uphill, that always confuses some people, but we read from left to right. So when you're going from left to right, a positive slope goes uphill and a negative slope goes downhill. Again, reading from left to right. Like that. Okay, so there's two things that always trip people up. A vertical line that your slope, m, is undefined. And a horizontal line, your slope is 0. So let's think about horizontal line. First of all, it's like the horizon. And so look at this slope. This slope is going up. This slope is going down. This slope is not going up or down. So it has a slope of 0. Whereas if I had a vertical line, that's impossible to have. Like, think about like walking up this and walking down this, walking across this. Well, I can't do anything like this. It's impossible. So it's undefined. So we're going to determine the slopes of the following lines. So I would make it easy on yourself. On these problems, just do rise over run. So how far, so start with 1 point. How far up does it go? It goes up 2, and it goes over 1, 2, 3. And notice it's going uphill, so it's positive. So try the other two. Okay, so notice this one is negative. That was the first thing that was sticking out to me, so I made that negative. And same thing, went down to over 3. This is what I was talking about here, so that slope is 0. Okay, number 2 deals with passing through 2 points, so we are going to gravitate over to this formula. So just keep it consistent. Don't worry about like which direction. I was taught to go from left to right, but you can definitely go from, I was taught to go from right to left, but you can definitely go from left to right. Just keep it consistent. So if you're going to go from left to right for your y's, you need to go from left to right to for your x's. So it doesn't matter your direction, just keep it consistent. So I have -1 minus 3, and then I'm going to do 2 minus -1. So this is -4 thirds. So the slope for this is -4 thirds. Okay, so I want you to kind of think about, without graphing, we want to talk about whether this is positive, negative, horizontal, or vertical. So go ahead and get your mind wrapped around that, and then we'll talk about it. So I wanted to point out a couple things that stuck out at me from a preliminary view. So remember that 0 on top is okay. So I had 1 minus 1. So that was sticking out to me that my slope is 0. So remember, a 0 slope is horizontal. This one, I knew that when I subtracted these, it was going to give me positive. When I subtracted these, it was going to give me positive. So in this case, I had a positive slope. Same thing, the opposite over for C. I had a negative over positive, which is a negative. And this is similar, D is similar to A, where I had 4 minus 4, but that was going to be on the bottom. So 0 on top is okay, 0 on bottom is no way, so that's undefined. So that's going to be vertical. So that's kind of that thought process that I go through. Let's go ahead and review parallel and perpendicular lines. Okay, so as you should remember from your algebra classes, parallel lines have the same slope. And they never intersect. So just basic knowledge. If you were solving for this, you would get like an undefined answer because they never come together. Okay, so then we have perpendicular lines. They have negative reciprocal slope. This means that their lines are going to meet at a 90-degree angle. So a negative reciprocal slope, let me give you an example. So like if the slope is negative 5/7, the perpendicular slope is positive 7/5. So negative and then reciprocal. So change the signs, flip the numbers. Okay, so we are going to tell whether these are parallel, perpendicular, neither. You've seen these before. So what you're going to do is find the slope here, and then kind of decide which one of those that'll be. Okay, so I found the slope for both of these. So now I'm just kind of evaluating what this means. So I have, once I simplified this 4/6, I got 2/3 and I have negative 3/2. So then I just found that these are perpendicular. So try the next one, number 5, and see what you get. So in this case, you don't have anything matching, so it's okay. This is going to be a case that it's neither. But let me propose to you that I change this to a positive. So let's do this in different colors. This would be a positive. So I have -2 plus 3 is, sorry, I said that wrong. -2 minus 3 is -5, and then I have thirds. So notice in this case, if I just change one thing, now they would become parallel. So I just wanted to give you all three options there. So this is point slope form, and it is just a variation of the definition of slope. So this is a definition of slope. And so if I multiply both sides by this bottom, I get x2 minus x1. Those cancel out. And so I end up with actually this side. Now, notice a little 2 is gone. That's okay, because we're going to use it for a little bit different purposes. But it's just the same thing as the slope formula. So I wrote out the steps how to graph in point slope form because it's just a little different. And so we're going to go ahead and graph these down here using this process. Okay, so on this first one, let's do two things at once. We're going to identify the slope and then find a point on the line from the equation. Okay, so where to look for the slope? We kind of already talked about it. That's this right there. And then a point on the equation, if I go back up here and look at this, we're going to do kind of the opposite because we have that negative going on there of whatever it gives us. So for instance, here I have x minus 1. So my x value is going to be 1. My y value is going to be 2. So that gives us a nice starting point. And so I'm going to start at 1, 2. I'm going to go think about rise over run. So I'm going to go up 3, 1, 2, 3, and to the right 1, or down 1, 2, 3, and to the left 1. Okay, notice that my dots are going up. That's what I want because it's a positive slope. Sorry, I kind of missed the mark there. Ugh, that looks hideous. Sorry, guys. Okay, so try to do 7 and 8 on your own. I'm going to change this to, let's make this a negative. Those are going to work out a little bit better. So I want you to change that to a negative and keep going. Okay, so this is what you should have gotten on these 3 problems. And we are going to move on to our last problem, which is a word problem. And I want you to kind of think about when you come to a problem like this, I really want you to think about like these types of problems where you're given 2 points. I think there's another place, yeah, right here, like where you're given 2 points. I want you to think about that when you're reading it and see if you can pull out 2 sets of points there. Okay, so hopefully this was pretty easy since it was a diagram, but this is my thought process, the way I go through this. So just go ahead and pretend that you just have these 2 sets of points now and you're finding the slope. So let's do that. Okay, so I want to stop here and kind of decode what this means. So think about this. This is like how much bigger it's getting over the years. It started out with, well, not started out, but in our data in 1965, it was 137 inches. And in 2005, it's 41 inches. So it's getting bigger. Okay, and then if it's every year, it's 10 inches. So we have 1 inch in 10 years. So if we're going to go up here and in 100 years from 1965 to 2065, if it's 1 inch every 10 years, how many inches in 100 years? So we can multiply this by 10 and this by 10. So our answer would be 10 inches. So our answer, let's go back to our coordinate point. So our answer is going to be 10 inches from this guy right here. So 137 plus 10 is 147 inches. Now you don't need this, but you're more than welcome to use it. Okay, so let's answer the question. So predict the sequoia's diameter. So it's going to be 147